Good morning, friends. In the last lecture, we have seen the numerical on torsion. Okay, today we will see again numerical on the same topic, torsion. But if you have given the efficiency or if you have given the velocity, then how to solve the given numericals? We will see. I have taken here two numericals. First on the hollow shaft and second is the combination of solid shaft as well as hollow shaft. Okay, then let's see. In the first problem, you have given the propeller shaft having the speed n is equal to 110 rpm. Okay, and that propeller shaft velocity is given 12 meter per second. Okay, you know the unit of velocity meter per second, and the power required to transmit that shaft is given P is equal to 6337.5 kilowatt. Okay, you should convert into the watt. How to convert? Into 10 raised to 3, and efficiency of that propeller shaft is given 68%. Then you will get the 0.68. How to get this? Divided by 100. Percentage means what? 100. 68 divided by 100, you will get the 0.68. And also you have given the diameter ratio d by d, small d by capital D is equal to 2 by 3 is given. Then we can convert into the relation. Say small d is equal to 2 by 3 capital D. Okay, and the stress is required to transmit induced in the shaft is equal to 8 megapascal. 8 megapascal. 8 megapascal. Okay, or we can say the Newton per mm square. Remember the unit 8 megapascal. D is equal to how much? We want to calculate small d, capital D is equal to how much, and we want to calculate also tau max. Guys, you know the formula for the torsion. T by J is equal to G theta by L is equal to tau by R. See, in this numerical, we don't given any length, we don't given this theta value or G value. Then you have to use this relation. T by J is equal to tau by R. Okay. Then how to calculate this J value? See, how to calculate this? We want to calculate the value of tau. How to calculate the tau value? In the first numerical, say T is equal to, we can write T is equal to J by R is into tau is there. Or we want to calculate the torque. See which value we don't know. T is not given. Okay, we want to calculate the T. Then after that, we want to calculate the J, polar moment of inertia for hollow shaft. Then tau, we want to calculate the tau. Then R. Okay, which R? We don't know the value of T. R means what? D by 2 is there. D by 2 is there. With the help of we can calculate. But how to calculate this torque? First, how to calculate this torque? We are going to the reverse direction, right? Reverse direction. T torque, how to calculate the torque? T is equal to 2 pi mt divided by 60. Okay, because power is given. We know the value of n. N is given. Then easily we can calculate the torque for that propeller shaft. Okay, once you have got the torque, first value we will get with the help of power. Then how to calculate the J for the hollow shaft? J is equal to what? Pi by 32 polar moment of inertia. This is the d raised to 4, or we can say the d raised to 4 minus di raised to 4 is there. d raised to 4 minus di raised to 4. With the help of you will get the second value. J is equal to, then how to calculate the radius, diameter of the shaft? Yes, how to calculate the diameter of the shaft? Okay, we don't know the any formula. Then see, diameter, it is related to the area. It is related to the area. Here the efficiency is given. We know this efficiency formula. Okay, we want to calculate the useful work done. It is the ratio of useful work done to the energy of that shaft. Energy means power of that shaft. Okay, what is the efficiency? Efficiency is equal to useful work done to what power or energy of shaft. Power of shaft or energy of shaft. Okay, what is the efficiency? It is the ratio of, in this numerical, useful work done divided by power of shaft. Then how to calculate that useful work done? Okay, we want to calculate that work done per second. Work done per second for that thrust. Okay, we know the thrust force. We don't know the thrust force, and velocity is given. Velocity is given. You should remember this formula: thrust force into velocity. Guys, remember, first check what is the given in the numerical and how to calculate the value with the help of given data. Okay, work done per second. How to get that work done per second? What is the unit of power? Watt is there. Then also we want the unit of work done per second in the watt. How to get this watt value? Then check that thrust force. We don't know this force. F we don't know. Then what is the velocity? Velocity is given 12. What is the unit of this force? This is in Newton. What is the unit of velocity? Meter per second. Newton meter per second is nothing but the watt is there. Watt is there. 12 watt. We will get the force work done per second. Then you should put this value in that equation. Okay. You have given the efficiency, then you should put the 12 here and power is given. Means you will get the value of F. Value of F. Here you will get the value of F. Once you have got the F, then easily you can calculate the diameter. How to calculate? Because stress is given 8 Newton per mm square. Check that. I will write the stress formula F by A. F by A. What is the stress? Stress is given. Okay. What is the area? How to calculate that area for the hollow shaft? Pi by 4 into dO square minus di square. Okay. With the help of that, you can calculate the value of dO or di because relation is given. Okay. All of you getting? This is the basic thing. You have to go to the reverse direction. Reverse direction. First check what we want to calculate and what value is given in given data and what value we want to calculate. That thing you know, then and then you can calculate the value. You can find out the value answers. Okay, then we will start. First we want to calculate. First is a what we want to calculate. We want to calculate first is a work done per second. Work done per second. How to calculate that work done per second? We know the velocity is given. Force into velocity. Plus force into velocity. Thrust force into velocity. What is the thrust force? It is denoted by F. What is the velocity is given? 12 meter per second. What is the unit? Newton meter per second. This is known watt. Okay. 1 watt is equal to Newton meter per second. Remember that. This is the first step. Then second step. What is the efficiency of that thrust? What is the efficiency of that thrust? What is the formula? Useful work done. It is the ratio of useful work done to the what? Energy of shaft, or we can say the power of that shaft. Energy of shaft or power of shaft, then we can put the value. What is the efficiency? 0.68%. Useful work done, we have calculated that value here. Then what is the energy of the shaft? Energy means power is given. Check that this power 6337.5 into 10 raised to 3 is there. Then you will get the value of F. What is the force? This force you will get 349125 Newton. Check that. Okay. Calculate. Then you will get 359125 Newton. Then next step is the third, diameter of the shaft. Once you have got this, then we can calculate the diameter of the shaft with the help of stress formula. What is the stress formula? Sigma is equal to F by A. Sigma is equal to F by A. Again, I will simplify that formula. F divided by pi by 4. What is the area of the hollow shaft? dO square minus di square. Right? Then put the values in this equation. What is the sigma? 8 Newton per mm square or megapascal. 8 megapascal is equal to, what is the F? We have calculated here 359125. Okay. Then pi by 4 as it is. What is the dO square? dO square as it is. Okay. Don't know the value of that dO square. Yes, check that. Pi by 4 d square minus, or we can write here capital D square minus small d square. Capital D square minus small d square. Check that. Here we are using the D for the capital D and small d. That's why I have taken here capital D square minus small d square. Then check that d square as it is minus, what is the d? Small d is equal to, we know the relation, d is equal to, small d is equal to 2 by 3 capital D. Put this in this equation, 2 by 3 capital D bracket square. If you solve, then there is a only one constant. There is a only one constant. Then you will get D is equal to 320.75. This is in mm. This is in mm. Okay. If you have calculated this, check that here is only one constant is a D is there. Once you have got the capital D, then put the value in this equation. You will get the small d. What is the small d? Small d is equal to 2 by 3 d means what? 320.75. You will get the small d is equal to, what is the value? And you multiply by this value, then you will get the 213.83 mm. 0.83 mm. This value you will get. Okay, this is your first answer. What is the diameter of the hollow shaft? This is the outside diameter. We have 320.75 mm, and this is the inside diameter, small d, 213.83 mm. Okay, once you have got the diameter, then easily you can calculate the polar moment of inertia. Okay, I will put this value in this equation. Next step, you have to find out the polar moment of inertia. You know the polar moment of inertia for the hollow shaft. Okay, remember which shaft is given. Check that. Polar moment of inertia pi by 32 into d raised to 4 minus d raised to 4 small d. Then pi by 32, put the value 320.75 raised to 4 minus 213.83 raised to 4. Check that is equal to, then you will get the polar moment of inertia value. Check the polar moment of inertia value 8338 point. This value will get 76 into 10 raised to 5. What is the unit of polar moment of inertia? Mm raised to 4. Mm raised to 4. Check that. 8338.76 into 10 raised to 5 mm raised to 4. Once you have got the polar moment of inertia, then next step we want to calculate the torque. How to calculate the torque? Use the power formula. P is equal to 2 pi n t divided by 60 is there. What is the power? 6337.5 into 10 raised to 3 is equal to 2 pi. What is the value of n? Revolution per minute speed is given 110. What is the value of t? Don't know. We want to calculate. Then here is it. You will get the only one constant. T is equal to, you will get 550,174 Newton meter. Guys, tell me how to convert into the Newton mm. Okay, when you calculate the tau value, then you will get this value in Newton per mm square, because d we have find out the mm. Okay, j we have find out in mm. That's why we want to convert that torque also in Newton mm. Then how to convert this? Okay, multiply by what? Yes, correct. 10 raised to 3 Newton mm is there. This value will get. Okay, and put all this value in the shear stress formula. Okay, T by J is equal to tau by R. Okay, check that which value we want to calculate. Tau value we want to calculate. Tau is equal to T by J into R is there. R is there. Then put the value. I'll put here T is equal to 5550174 into 10 raised to 3 is there. What is the value of polar moment of inertia? 8338.76 into 10 raised to 5 is there. Okay. What is the value of R? Check that. What is the value of R? Which value you will choose? Choose the maximum value. You have to take the outside diameter of the hollow shaft. 320.75 divided by 2. D by 2 is there. Then what is the value of tau? You have to check. Tau is equal to 105.8. What is the unit? Newton per mm square or mega Pascal. This is your answer. Okay, all of you getting how to solve this type of numerical? We will ask in the examination for 6 to 7 marks. Clear? Any doubt? Okay. Then next numerical. Check that the next one. What is the given? You have to calculate the power ratio. Here is a combination is given. The solid and hollow shaft. Okay. What is the value of solid shaft? Diameter is given. Solid shaft diameter is given. ds is equal to 180 mm. Hollow shaft inner diameter is given 130 mm. And you have given the both shaft cross section are same. Means area of the hollow shaft is equal to the area of the solid shaft. That things are given in your numerical problem statement. Then we want to calculate the ratio of solid shaft power to the hollow shaft power. Then how to calculate this type of numerical? We'll ask. Then see, first you have to calculate. Use this relation and find out the diameter. Which diameter? We want to calculate hollow shaft outer diameter. Inner diameter is given, but we don't know the outer diameter. Then we want to calculate which value? DO value. I will use the same relation. Check, guys, if you have given any relation, then think about that relation first. A solid, A hollow is equal to A solid. What is the area of the hollow shaft? Yes, anybody? We know, we have seen pi by 4 into DO square minus DI square is equal to. What is the area of the solid shaft? Pi by 4 into ds square is there. ds square is there. Okay. Then we want to calculate the value of, put the value, this pi by 4 get cancelled. DO, we don't know the DO. We want to calculate DO square is given. And what is the value for the solid shaft diameter? 180 square is there. If you have calculated DO is equal to, you will get 222 mm. Okay, this is the outside diameter of the hollow shaft. Okay, if the again they are mentioned in the problem statement. Okay, there is a angular velocity of the shaft are same. Angular velocity of shaft are same. What is the meaning of that? Angular velocity of the solid shaft is equal to angular velocity of the hollow shaft. If the angular velocity of the solid shaft is equal to the angular velocity of the hollow shaft, then there is a shear stress induced in the shaft also same. Guys, remember that if there is a angular velocity are same, then there is a again you will get the same value for the shear stress. Shear stress induced in the solid shaft is equal to shear stress induced in the hollow shaft. If the shear stress induced in the solid shaft is equal to hollow shaft, then check that we want to calculate PS by PH. Okay, then you will get PS by PH is equal to, I can write PS by PH is equal to, you know that the formula T by J is equal to tau by R is there. Okay, then you can write T is equal to what? T is equal to what? J by R into tau is there. What is the J by R? Yes, we have seen J by R is the sectional polar shear. ZP is there, ZP, and tau are same. That's why we mentioned that tau. You will get the new relation. T is equal to ZS by ZH. ZS by ZH is there. Then what is the value of ZS? We have seen in the first lecture of the torsion how to calculate the formulae for the solid shaft and hollow shaft. What is the sectional moment modulus for this solid shaft? Yes, anybody? Yes, pi by 16 into ds cube is there, right? Ds cube is there. And what is this? Pi by 16 do. Pi by 16 do into, yes, anybody? Do raised to 4 minus di raised to 4. Yes, very good. Okay, you know the sectional modulus for the solid shaft and hollow shaft. Then pi by 16 into ds cube divided by pi by 16 do into do raised to 4 minus di raised to 4. Then put this value in that equation. Pi by 16 into, what is the value of ds? 180 cube divided by pi by 16. Pi by 16 you can cancel this. What is the value of do? Do we have calculated 222 into 222 raised to 4 minus, what is the value of the 120 raised to 4 is there. If you have calculated this ratio PS by PH, then you will get 0.604. Okay guys, you will ask this type of numerical. If you know the basic thing, if you know the angular velocity of the given shaft, solid shaft is equal to the angular velocity of the hollow shaft, then you know that the shear stress induced in both shafts also same. That's why we will get the new relation PS by PH is equal to TS by TH is equal to ZS by ZH. Okay, again what is the ZS? It is the ratio of polar movement of inertia to the radius of that shaft. Okay, or with the help of that equation also you can calculate for the solid shaft as well as hollow shaft. Okay, thank you. Today we will stop.